All right. So we are studying chapter 12.1 and 12.2. And this is the third page of your 12.1, 12.2 homework assignment. So I'm going to get you started here as well. This is going to be very similar to the last page where we're going to start with a proof of a new theorem, and then we're going to have a few problems where we practice using that theorem. So I'm going to walk you through this proof and then help you get started on one of the problems below. Okay. So on page 590, you'll see the exterior angle theorem. Okay, and this one says the measures of an exterior angle of a triangle, which would be like this guy right here, is equal to the sum of the measures of the two non-adjacent interior angles. So first we've got to break that down and figure out, like, what does that even mean? Okay, so remember that an exterior angle of a triangle it's like one of the sides, if we extend it, makes an angle with one of the other sides. So when we extend the sides of these, we get these like exterior angles here, right? So exterior means like outside the triangle. So what we know is the interior angles, angle A, B, and angle A, and angle 2, if we add all those up, we're going to get 180. This was just saying, well, what about the exterior angles? So the measure of this exterior angle right here, angle 1, is equal to the sum of the measures of the non-adjacent interior angles. Okay, so we're only looking at one exterior angle right now, and we want to say that we're going to add this, and it's going to equal this outside one. That's what's going on there. Okay, so exterior angle, interior. The other thing it says is non-adjacent. So notice that angle 1 and angle 2 are adjacent because they share, a ray. So when we talk about the sum of the measures of the two that don't touch number 1, so these two guys. So what we're at to prove here is that this angle plus this angle is going to be equal to angle 1. Now one thing that I wanted to mention that's kind of important is how do we name angles, okay? So we call this angle A and this angle B. How come we don't call this angle C? Well, the reason why is there's two angles that are using C as a vertex. Right, there's this angle right here, which we named angle 2, and there's this angle here, which we named angle 1. If we tried to call one of these angles C, it wouldn't be clear which one we're talking about because both of them have a vertex of C. Okay, and so that's why we're using this angle 2. If we didn't have that number 2 labeled, we'd have to say ACB and BC whatever. We'd have to have another point out here to label those two guys, because they both use the vertex C. So we can't call this angle C. We have to either call it BCA or ACB or number it, and that's why I put a 2 there. Okay. All right, so let's start out with our given. And I'm not sure how many lines we'll need. I just kind of put 5 in there, but we might need another one. We'll see. So triangle ABC given. Okay. All right, so we're going to use the theorem that we just proved to say that angle A plus angle B plus angle 2 are equal to 180 degrees. Okay, so we know the triangle sum theorem tells us the measure of angle A plus the measure of angle B plus the measure of angle 2, right? We can't call it C, we're going to call it measure of angle 2, is equal to 180, and that's the triangle sum theorem. So in our axiomatic system, we're using theorems to prove new theorems. Okay, we also know that these two angles have to add up to 180, right? Because they form a linear pair. So if we ignore the rest of this triangle here, we got this linear pair, and those have to add up to 180 degrees. So we know the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Again, we know that because we have the linear pair postulate. Right, two angles that make a linear pair have to add up to 180 degrees. So now hopefully you're starting to see what's going on here. We can do a substitution, right? Because these are both equal to 180. So the measure of angle A plus the measure of angle B plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 2. Substitution prop of equality. Okay, now we're almost there, right? If we can just get rid of these angle 2's, then we're good. And we can do that because we can just subtract them from both sides like an equation. So measure of angle 2 obviously is equal to itself. So if we subtract measure of angle 2 from both sides, we're going to get measure of angle A plus measure of angle B equals the measure of angle 1, which is what we wanted to prove. And that's going to be subtraction. So this one was substitution. This one's subtraction. Prop of equality. Cool. We're done. So kind of cool. If you've been following along with the other proofs that we've been doing, the angle proofs that we've been doing, this is very, very similar to some of the other angle proofs. So as soon as we get that triangle sum theorem, we can start proving all kinds of fun stuff. Okay. So there's your proof. Now let's use that, practice using that, and we'll figure this one out here. Okay. So we want to use the exterior angle theorem, which we just proved, to set up an equation and solve for x. Okay, now in this one it doesn't ask us to plug it back in to find an angle, so we're just looking for x just to use that theorem. So notice here we have an exterior angle, and then we have the other two, the non-adjacent interior, right? Non-adjacent because this angle would be adjacent with this angle, but these are the two non-adjacent ones. So there's three interior angles of the triangle, this guy, and there's this one that's not labeled, and then we have one exterior. So what we know from the exterior angle theorem is that 23x minus 3, the exterior angle, is equal to the sum of the two non-adjacent interior. Right, so we just set up our equation there, and we're going to solve it. So we're going to combine like terms. So this looks like 23x minus 3 equals 40. 40 minus 3, we'll do a 37 there, plus 15x. Okay, we're going to group the x's on the left, and we're going to group the numbers on the right. So we're going to go minus 15x, minus 15x. Make sure you can see that. So this one's gone. Let's see, 23 minus 15 is going to give us 8x minus 3 equals 37. Okay, we're going to add 3 on both sides. Plus 3 plus 3. So 8x equals 40. And then divide both sides by 8, which is going to give us 5. X equals 5. Okay, so that's how you do it. Now these are all going to be pretty similar. You're just going to use this theorem, but the idea is to set the exterior angle equal to the sum of the two non-adjacent interior. That will give you your equation, solve it for x, and then you're good to go.